Hello, welcome back. Today we are doing lesson 12.1.1, analyzing trig equations. And in this chapter, as it says right over there, you should do your work in radians unless the problem tells you otherwise. So, for 12-1, how can you tell which values of x make an algebraic equation in one variable true? For each of the following equation, decide that the equation is always true, sometimes true, or never true. If it's always true, justify how you know. If it's sometimes true, give the exact values of x that make it true. And if it's never true, explain why it's never true. So for these problems, you guys understand what these means, but we're gonna help you think about it mathematically. It's the way of thinking, because then once we get to 12-2 and obviously the next few lessons, this is going to be a key part of this, understanding, giving out reasoning and all that stuff. So let's get started. So for this first problem, I'm going to distribute the 5, and then I'm going to get 5x minus 35 equals 5x minus 35. And as you can tell, they're equal on the left and the right. So I'm going to write it's always true, right? And let me highlight that. So now I have to explain, why is it always true? You know it, I know it, but can you explain it mathematically? So I'm going to write, get the same value on both sides for any value of x, right? I could put 1/2, negative 2/3, one decimal point that goes on to infinity, and I will always get the same answer on both sides. So let's move on to the next one. That was doable. So I started off by dividing both sides by 2 and isolating x. For most of these problems, I will isolate x. So I divided by 2, I get x squared equals 25, right? I can square root both sides, and I will get x equals, absolute value of x equals square root of 25, which can also be x equals plus or minus 5, right? So, because I only have 2 answers, it's sometimes true. But you're telling me, well, it's always true because you found the 2 answers. No, it has to be true for all values of x, but we only found 2 values of x that worked for this problem. So don't get those 2 mixed up. Sometimes true. Let me highlight that. All right, so now I have to explain how I got that. So I'm going to use, say, left side equals 50 if and only if x equals 5 or x equals negative 5. So I'm using the term if and only if because that is another mathematical way of saying it only has 2 answers. You can use if and only if x equals like 3 or whatever your answer may be, but that's how you share your answer in the mathematical sense. And get yourself used to writing like that. Very important. 2, 5 squared equals 50, that checks out. And 2 to negative 5 squared also equals 50, and that also checks out. So I also proved that they both equal each other with 5 and negative 5. So the reason we use this language is that there isn't any, ambiguity. Words are hard this morning. When people are sharing their findings and whatnot between other mathematicians. So that's why we use this very definitive language when describing that there's only 2 definitive answers. Because it can be easily interpreted as being a little bit more flexible when, you know, the point you're trying to make is that it's not flexible. So let's move on to the next two, C and D. And I'm going to start by distributing the negative. So I'm going to get 4x minus 3x minus 2 equals x minus 7, right? So now that I have those two, I'm going to get x minus 2. I'm going to draw an arrow because I don't want to run out of room. X minus 2 equals x minus 7. And then I'm going to get 2 equals 7 after I get rid of the x's. So I know that this is never true because you can never get two equal answers. There isn't a value of x that would give you that would make this equation correct. So never true. All right, so now how do I state that in words? You just basically state there is no value of x, value of x to get an equal value on the left and right sides. So you could state it that way. Very discrete, very descriptive. We didn't need to use if and only if because it was not sometimes true. All right, so let's do D. So I'm gonna multiply everything by 12. So this whole thing is gonna be multiplied by 12. So I know that the 4 disappears, and I'm left with 3. 3 times 3, and then I know that 3 disappears, and I'm left with a 4. 4 times 2. So then when I bring it down, I get 8x minus 9 equals 9, 2x plus 5, right? And then distribute after that. I'm gonna get 8x minus 72 equals 18x plus 45. And then I just continue solving for x. Add 72 to the other side, and I get, I'm gonna subtract 8x because I want the x's to be positive, and I want the this to be negative. So I'm gonna subtract 45 and subtract 8x instead. So I'm gonna get 10x equals, subtract 45, negative 117. Wow, doing that all in my head. Believe me, don't believe me, your choice. You know, you divide by 10. This one's easy. 11.7. Just move the decimal place over once. All right, since I'm given only one answer, so x, I can't use the above statement because I don't have a definitive answer. I can say left side and right side equals each other if and only if x equals negative 11.7. So that's what I'm going to state for my answer. But first I'm going to state it's sometimes true, right? Sometimes true. There we go. And then I'm going to say left side and right side equal each other if and only if x equals negative 11.7. So that's how I would write that. If you have any questions about this, feel free to ask me in the upcoming week. I'd be more than happy to answer any questions you might have regarding these concepts. All right, let's do the last few, because now we're gonna decide if each equation is always true, sometimes true, or never true, and then we're gonna justify our answer. So by looking at sine of x equals 1/2, I know it's sometimes true because I only have 2 answers if I go 2 pi around. But we'll discuss what that means in this problem. So sometimes true, right? There we go. And now I have to state when x equals pi over 6, which is in the first quadrant, and x equals 5 pi over 6, which is in the second quadrant. Because we know all of them, sine, cosine, tangent, are positive in the first quadrant because it's positive 1/2. And we also know that sine is positive in the second quadrant. Now you just got to figure out which one gives you 1/2, and it's pi over 6 and 5 pi over 6. That's why I asked you to memorize the unit circle. So I'm gonna write these are the answers for one cycle. Right? Because we can go around another 2 pi after we've gone around 2 pi. So we can have a lot of coterminal angle, a lot of other x values that are coterminal angles. Why did I stop myself? I was correct. So we can get infinite answers by adding multiples of 2 pi. And then we have to show that. Thus, x equals 5 pi over 6 plus 2 pi n, or x equals pi over 6 plus 2 pi n, and then n equals 1, -1, 0, 1. So it goes from negative infinity to infinity. That's what n can be. Any integer from there. So doesn't matter, 2 pi round, 2 pi backwards because you used the negative. These are all the coterminal angles that x can equal. But it's sometimes true because it's not every value of x, or every value of x. So let's continue. Cosine of x equals 2, right? Let's do that one. And that is never true. I hope you guys recognize it right off the bat. You're like, wait, I've never seen an answer be 2 before. You're right. Never true. Never. Because cosine has to be in between -1, less than or equal to, cosine of x, less than or equal to 1, right? I mean greater than or equal to for that one. So this is the reasoning why, because cosine has to be in between -1 and 1. Can't exceed any values left or right. So let's do tangent. Tangent of x equals 0. Sometimes true, right? When it's on the 180 degree line or 0 degree. But do you remember that in radians? Remember, all answers in radians. So I'm going to write sometimes true. So for x equals 0, x equals pi, x equals negative pi, and so on and so forth. Or we could say, in general, for any multiples of pi. Right? So, whoops. Oh man, I was trying to draw an arrow. X equals n to the pi. And what is n? N's going to be the same thing I wrote for a. N equals ... -1, 0, 1, ... So saying from negative infinity to infinity. It's another way to say it. And that proves that it's sometimes true because it's multiple of pi. All right. So D and E. They might look scary, but they're not. So if we look at that, sine of x equals cosine pi over 2 minus x. And remember, how do we shift to the right? Well, pi over 2 shifts it to the right to make the cosine graph look like the sine graph. So this cosine of pi over 2 minus x does equal sine of x. I would look at last week's lessons if you are confused and you don't understand that, because I did show you guys an example of, we did shifters and whatnot between sine of x, cosine of x, and look at those shifters again. Even try graphing this, and you'll see that cosine of pi over 2 minus x lands right on top of sine of x. And let's just do some examples, because you guys might be skeptical. Wow, words are really hard this morning. So, you guys might be skeptical at what I'm telling you. Like, oh, you're lying. Can't always be true. Watch this. If x equals pi over 2, right? We'll get... Well, I hope you can hear that guy racing down the street. It's a free-for-all. So sine of pi over 2 equals cosine of pi over 2 minus pi over 2. Right? So cosine of essentially 0. That was terrible. So cosine of 0 equals sine of pi over 2, which they do equal, because cosine of 0 equals 1. Sine of pi over 2 equals 1. 1 equals 1. That checks out. So why not? What about pi over 4? Right? You're like, well, that's pi over 2. Pi over 4. Sine of pi over 4 equals cosine of pi over 2 minus pi over 4. So we're going to get negative pi over 2. All right? And we know that cosine is positive in that quadrant of negative pi over 2. X value, negative. So quadrant. Can't remember the quadrant. Quadrant 2? Yeah. So we're going to get root 2 over 2. Oh, no. That's going to be positive 3 pi over 4. Never mind. So we're going to get, but they're both going to be in quadrant 1. The square root 2 over 2. Right? And that checks out as well. So if you are still confused, not confused, if you still don't believe me, plug in more x values. Check it out. See it for yourself. Use your calculator if you want to plug in x values of like 0, 3, not radians. But radians are the easiest because you don't have to use your calculator. Hopefully. All right. So I'm going to divide by 2 for e so I can get sine by itself. So I'm going to get sine of x equals square root 3 over 2. And you can do that because it's on the outside and not on the inside right there. So, since this is what I got, I know that this is sometimes true, right? There's only so few x values that will give me root 3 over 2. Let me highlight that. The reference angle for root 3 over 2 is, hopefully you guys answer that, is pi over 3, right? So I know that it can, we're going to state all the coterminal angles for this as well. X equals pi over 3 plus 2 pi n, and x can equal 2 pi over 3 because that also gives you a positive root 3 over 2. There's always 2 that gives you a positive. plus 2 pi n. And n equals, you have to state what n is, -1, 0, and 1, right? You could put negative infinity to infinity if you wish, but this shows that it's all integers ranging from negative infinity to infinity. So, yeah, if you have any questions, ask me this upcoming week, and more than happy to go over this. All right, thank you.